Hello guys, in this video we are going to discuss the solution of the problem minimum distance between two given nodes of a binary tree. So let us look at the problem statement. The problem statement says that we are given a binary tree with n nodes and two node values a and b. So these many things are given to us, which is a binary tree and two node values a and b. Our task is to find the minimum distance between them. Okay. So the given two nodes are guaranteed to be in the binary tree and all nodes are unique. So let us try to understand the problem with the help of an example. So let us say a binary tree is given to us, and let's say the content of the binary trees are something like this, right? So 1, 2, 3, 4, 5, 6, 7, let's say 8, and the two nodes which are given to us are this node, let us say this node, and let's say the other node which is given to us is this node. Okay, and with these two nodes, so this is A and this is B. So with these two nodes, I need to find, or we need to find the minimum distance between these two nodes. So the minimum distance between these two nodes is, let's just count it. So 1, 2, 3, 4. So the distance between node A and node B in this particular case is 4. Another way of looking the problem, you find a common node between these two nodes, and the common node will be our least common ancestor, isn't it? So this is the least common ancestor which we have, or this is the common node which we need to find. So let us say this is my common node, and the common node will be our least common ancestor as well, LCA. So we will find the least common node for the node A and B, and once we have found the least common node, the distance between A and B can be rewritten as what would be height of A from the LCA plus height of B from the LCA, right? So what I'm trying to say here is, in order to find the distance between the two nodes, what the first thing which we will do is that we will find the LCA of the node. Once we have found the LCA of the node, then what we are going to do is that we want to find the height of node A from the LCA node. Okay, and then again we want to find the height of node B from the LCA node. Okay, so in this case the height is 2, and here also the height is 2. So because of which the distance between A and B will be 2 plus 2, which is equals to 4. Okay, so concept wise or solution wise, we understand that we need to find out two things. Number one thing, so the number one thing which we need to find out is find LCA of A and B. So that's the number one thing which we want to find out. Once we have found out the LCA of A and B, we need to compute the height of A from LCA, okay, and we need to compute the height of B from LCA. And once we find out these two things, we would be able to add these two things, and that will be our distance of the node A and B. Okay, so now let us see how we will be able to find LCA and how we will be able to find height of node A and B from LCA at the same time. So that's the trick here. We need to find the LCA as well as the height in one iteration itself. So let us see how we are going to do that. So let us say that this is our binary tree. Okay, let's say these are some of our nodes which we have. So as you can see, the content of the nodes are not important here, so I'm just drawing it something like this. Okay, and let us say we want to find the uh, distance between this node and this node. Okay, so this is our node A and this is our node B. Okay, so first thing what we are going to do is that we will start from root, and while iterating the elements we will go ahead and update the height of the tree. Okay, so right now we are at this position, so the height is 0. When we will come to this position, what we are going to do is we are going to increment our height by 1. So this becomes 1. Again, next level, so we are going to iterate, increment our height by 1. So this will be 2, and this again will be 2, and here also we are going to increase it by 1. So both the cases it is 3. Okay, so we will iterate on the nodes of the tree, and while iterating we understand that we will be storing height of the tree as well, and that is something which will be there. So at each node we will know what is the height at which this node is, and this height is from the root node, right? Now once we see that we have reached to, so case 1, once we see that we have reached to node A, right? So let us say, so this is how we will check whether we have reached node A or not, right? And if you see, if we have reached node A, then what we are going to do is we are going to update our height of A equals to height, right? So the height variable stores the current height at which we are, and height A is a global variable. So let us say this is our global variable height A, and similarly this is again our global variable height B, and then there is one more global variable which we need, which is height of LCA node. Okay, so the case 1 is this, where we see if we have reached a particular node A, then we are going ahead and updating the height of node A. Similarly, if we see we have reached at node B, so this will be something like this, right? If we have reached at node B, then we are going to say we are going to update the height of Bth node to the current height which we are at. Okay, so these two things, so this is how we will be able to know the height of the tree. Now height of the node A and node B. Now the things which are pending now for us is, how do I update this, which is height of LCA? That is number 1. So the number 1 is height of LCA. How do I update this? And the second thing which we need to do is find LCA. So let us see how we would be able to find LCA, and at the same time we will be able to update the height of the LCA as well. So let's see, this is our function which we want to write down, which is LCA. We want to find the LCA for the root tree root, and the nodes are A and B. So the first thing which we are going to do is we are going to check if root is equals to none, right? If root is empty, okay, or by iterating we have come to the end of the tree, then we are going to return none, right? The third step would be we will check, so this is what we have discussed it, if root dot data is equals to A, then we are going to say that height of A is equals to a height. So one more thing, we need one more variable here, which is height of the tree, or the current height of the tree. Okay, so we are going to update it to height. The fifth step is if root of data is equals to B, then we know that height of B is equals to height. All right, now the seventh step. So okay, so here when we are doing it, what we have to do, so I think I missed some steps, so skip the numbering. so see this, once we have found the root dot data equals to a, so if we found a, then we are also sure that we have found the LCA as well, and that is why we are going to return root in this particular case. Okay. Similarly, and I'll explain these things. Similarly, if I have found B, then what I am going to do is, after that, I am going to return root. Okay. The LCA is root itself. That is why I am going to return root. Okay. Now, if this is not the case, then we are going to check for LCA in the left side of the tree. Okay, so if the LCA is not found so far, then we are going to check the left side of the tree, and while iterating on the left side of the tree, I am going to increase my height because by 1, right? Because I am now going to the next level. Similarly, I will also check the right side of the tree. So right is equals to LCA of root dot right a b, and here also we are going to update our height by 1. All right. Now, after looking into the left and right subtree, we will check if left and if we are able to find node A or node B in the left side, and we are able to find node A or node B on the right side. If we are able to find node A or node B, any one node on the left side and the other node on the right side, then this is the LCA, and this is what we are going to return. So before going, so this is the LCA, right? So if this is the LCA, so here is where we are going to go ahead and update our LCA by height of LCA by equals to height. Similarly, on the third step, since this is the LCA, so we are going to return root. All right. In the 13th step, what we are going to do is we are going to check if left, right, then we are going to return left. So here what happens is that we checked for left and right, but what happens is it might be possible that either left is both the left and right are not set, or one of the node is none. In that particular case, these things will be executed. So we will check if left is left is not none, then we are going to return left. Otherwise, we are going to return right. All right. So that's the code for LCA, and we can see that while finding the LCA of a tree, we are also going ahead and updating or finding out the 3 variables which we need, which is what? Height of A. So this is one which we need. Okay. The other we need is height of B. This is the second one. And the third which we need is height of LCA, which is over here. Okay. So most of the test cases, or we will be able to cover all cases with this code, but it might be possible that there would be some cases which will not which will fail on this particular code, and let us see what we have to do for those code and what are such test cases which are going to fail. So let us say there is a tree of this sort. Okay, let me just draw it properly. Okay, so the shape doesn't matter, but what I'm trying to say is, so let us say this is my node A and this is my node B. So here if you see, the LCA is this, right? Now the LCA is this, right? Now what happens is, since now if you look at the code, what will happen is we will see that root.data equals to A or root.data equals to B. So one of these two conditions will be satisfied. Either this condition will be satisfied or this condition will be satisfied. In both the cases, I will either go ahead and update height of A, or I will go ahead and update height of B, and after that I'm going to return, isn't it? Now since I am returning, because of which I will be able to update just one height, which could be either height of A or height of B. So I will be returning just one height here, which could be height of A or B, and the other two heights, which is height of, so one which we are not able to update is height of LCA, and so let us say height of A got updated, right? So in that case, height of B we will not be able to update. Now since we are not able to update height of B, thereby we will not be able to find the distance between the nodes. So in that case, what we are going to do is, so our LCA will give, so at least our LCA will give us the LCA. Okay, so LCA is equals to, let us say we will invoke something like this, or rather let me write down the entire code so that it makes sense. So let us say we want to find the distance between A and B, and root is given to us A and B. So the first thing which we are going to check is if so we are going to find the LCA. So LCA is equals to LCA of root A and B, and height we are going to pass. So initially the height is 0, right? Now the LCA is known to us. Now if the test case is not of this nature, okay, if the test case is not of this nature, then height of A, height of B, and height of LCA will be populated. So we are going to check if height of A, and let us say the initial values of height of A, B, and LCA is -1, and height of B is not equals to -1, and height of LCA is also not equals to -1, right? So in this particular case, we know that the height got populated. Now since the height got populated, we will be able to go ahead and compute the distance between the node. So let us compute the distance between the node and return it. So the distance between the node will be, right, so height of node A minus height of LCA, right? Height of LCA, right? If you see, we are computing the each height. So height of, so in this example, if you see, the LCA is this. So the height of LCA is what? 1, and the height of node A is what? 3. So if I want to find the height of node A with respect to the LCA node, then all I have to do is 3 minus 1, so which is equals to 2, and that is what we need. So this is what we are trying to write down over here, is if I want to find the height of A, then height of A minus height of LCA. Similarly, if I want to find the height of B, then height of B is equals to height of B minus height of LCA. So we found this height and we return it. Now it might be possible that we were not able to update height of A, right? So if we are not able to update height of A, then the height of A initial value will be -1, and that is what it will be. In which case, so these are the cases of this nature, right? So of this nature, we know the LCA, and we know A, and we know B, right? So here in this particular case, since height of A equals to -1, so what will happen is that B and LCA are the same, right? LCA, and so here in this example, for instance, LCA and A are the same thing, right? All I have, in order to find the distance, all I have to do is I need to find the height of B with respect to A. Okay, so let us find that. So that will be equals to height. So this is another function which we are going to write, and we will see how to write this. Height of A from LCA. Okay, please note here height of A is equals to -1, which means I was not able to populate the height of A. Okay, here in this particular case, if height of A we were able to populate, So that means height of B we need to calculate, and this is what we are going to return, and this will be our return. Okay, return. Now let us see how we are going to write the function height. Okay, and that is how we will be able to conclude this problem. So let us look at height. So root, and we want to look for some node x or some data x. Okay, so what we are going to do is that we are going to write we are going to do a level order traverser. So the level order traverser looks something like this. So we need a queue there, and we are going to put root at the beginning of the node, and after, so as we know, in the level order traverser, what essentially we do is, let me just draw a tree. As and when I go ahead and finish all the node of a tree, so what I mean to say is that I am at this level. Once I have consumed all nodes of this level, I'm going to go ahead and append a none variable in the queue. So since I have consumed, so the root contains only one element, so I have consumed all the elements of the root. So now I'm going to go ahead and put none in the queue. Okay, and then we will have some variable, let us say level or height, which will contain our height of the node. And then the fifth one is basically we are going to say while queue is not empty. So while queue is not empty, let us do this. So the first thing which we are going to do is we are going to uh, dequeue queue.get. We have dequeued it. Now since we are putting a none also, so it might be possible that the root we have just popped out is none. So that is what we are going to check. If root, right, so that means it is not none. Then so if root is not none, then what we are going to do is that we are going to check if root dot data equals to x. If that is the case, then we are going to return level. Otherwise, let me use separate page here. So we are here, and otherwise, if so this is here. Okay, if root is null, then in that particular case, what I am going to do is I am going to increase my level. So now I am going to the next level, right? So I'm going to increase my level by 1, and at the same time I am going to check if and we need to insert none. Since I have consumed all the elements, so none simply means I've consumed all the elements, so the level is finished, so I need to append none there. And before inserting none, I just need to ensure that queue is not empty. Okay, so if queue is not empty, then we are going to go ahead and put none to it. Okay, now in the 14th step, and this will be outside of this else block, if root and root left exist. Okay, in that case, what we are going to do is we are going to put or insert root left into our queue. Similarly, if root exists and root right also exists, then we are going to put the right side into the right. Okay, so this will be our 17th step, and that's the end of the height. So in this way we will be able to find the height, and we are going to return the height. Okay, so that's about the explanation, folks. Now let us jump to the coding section and see the code for it. So I've already coded it, and the code is pretty much the same. So what we are going to do is we are going to have these three variables, which is height of LCA and height of A and height of b. An initial value for all these three variables is -1. Then we are going to find LCA of a and b from root, and there is a height. So same thing, this is our base case, and let us say if I am able to find a, then the height I have updated it and I am going to return root. If I see b, then height I am going to update it and I am going to return root. Otherwise I am going to check the LCA in the left and right node, okay, left and right subtree. If left and right subtree both are found, then the height of LCA is this, and we are going to return root. Otherwise, if left, then we are going to return left. Otherwise, we are going to return right. So in this way, we will be able to find the LCA. Okay. Now let us look at the function which is used to find the height. So height is equals to, so like I said, we are going to do a level order traversal here. So root and none, and the level equals to 0. Then while queue is not empty, we dequeue an element from the queue. We check if the dequeued element is none or it is not none. So if it is none, in that case, I'm going to update my height by 1, and I'm going to insert none into queue if queue is not empty. Okay, otherwise, root.data, if I'm going to check if I have found the node I am looking for, which is x. If I found it, I'm going to return the level. Otherwise, insert the left and right node if they exist. And this is the code for find distance. So first you invoke LCA. If the, so this is for the first case, you compute height and then you find the distance between node A and B, and this is for the remaining cases. Okay. Now, so that's about the code, folks. Now let us submit the solution. So our solution got accepted. So that's from this video, folks. In case if you have any questions or comment regarding this video, please feel free to use the comment section and I will try to address them. Thank you.